Hi student, how are you? Hope you are fine, good and great. Okay, in this part of the circular motion, we are going to study linear or tangential speed and angular speed. Now, what is linear speed and what is angular speed? Let's see on the next page. Okay, linear or tangential speed. Tangential means the touching, like the circle. Let's suppose this point is called tangent to the circle, or this point is called tangent to the circle. This is called tangent. Okay, the length of the arc traveled by the object in a unit time is called linear speed. Now, what is the meaning of length of the arc? Like in the angular displacement, we know that this path is called arc. So now if the object reach from A point to B point, how much time is needed to cover this path or the length of arc? So this is called linear or tangential speed. So we know that speed is denoted by V, and for the linear speed we wrote the formula distance divided by time. So here in the tangential speed, we again this same like the for linear speed, instead of distance we will put the arc. We will use the arc, and time is time. Okay, we can use instead of arc, which like arc is denoted by S, we can also write by S over T. So this is the linear or tangential speed. Okay, in one complete revolution, like let's suppose if the object start from A point and again reach to the A point, so the S is equal to 2 pi r and T is equal to time period. T is equal to time period. Now if we put this formula, like if we use the value of S 2 pi r and T is equal to time period, and we put these two value in the tangential speed, now the tangential speed become like S over T. So now S is equal to 2 pi r and T is equal to time period. So we can also write like this, and we know that F is equal to 1 over time period. So we can also write this formula is equal to 1 over T into 2 pi r. So 1 over 2 is equal to frequency. So we can write like this 2 pi r into F. So this is also the formula which is used for the tangential speed. Okay, the next page we are going to know about the angular speed. Now what is angular speed? In angular speed is the rate at which an object change its angle in a given time period. Let's suppose how much time, for example, this is A point, this is B point. If the object, like in every second the angle theta is changed if the body is moved from A point to B point. So if we have the distance from A to B, so how much time is taken to change this theta? So this is equally what angular speed. Let's see the definition. Angular speed is the rate at which the object change its angle, like this angle, how much time is taken by this object to change this angle in a given time period. It is measured in radian, like the unit of angular speed is radian. Remember, this is not W. Simple, we can also write omega. This is called omega is equal to theta over time. Theta mean what? Angle, this angle, and how much time taken by the object to move on the circular path and to change this angle. So this is called angular speed. Okay, in linear speed we put this arc value, but in angular speed we will use this theta. The time is same, like V is equal to S over T for the linear speed or tangential speed, but here instead of s we will use theta, mean this angle, and linear or tangential speed denoted by v, but this is denoted by omega. Okay, in one complete revolution, like again in one complete turn, we know that t is equal to time period in theta. This theta will be equal to 2 pi radian. So if we use this value here in this formula, like formula is equal to theta divided by t. So if the t is equal to time period and theta is equal to 2 pi, instead of instead of theta we can use 2 pi radian and divide by t. So we can also write like frequency is equal to 1 over time period. So this will be 1 over time period into 2 pi radian. So we can also write this formula f 2 pi radian. So this is the formula which is used for the angular speed. Okay, next one, let's see the unit of omega or angular speed we can also write in radian per second. This is not usable, but usually we will use radian per second. So we know that the tangential speed is equal to 2 pi r and angular speed is equal to 2 pi over t. Okay, let's see here. Tangential speed is equal to 2 pi r and angular speed is equal to 2 pi over t. So if we compare these two parts or cross multiplication, so we can find the simple equation omega into radius. So this is the angular speed. So okay, dear student, hope you learn something and learn the difference between the linear or tangential speed and the angular speed. Okay, next video inshallah we are going to study some example of the linear and tangential speed. So just keep watching us, being stable with us. Thank you so much.